Hi friends, welcome to the Unit 3, Day 3 notes. Today we're going to be talking about what value of x that we can have for these particular problems to give us a quadrilateral that is instead a parallelogram. So this uses kind of the rules that we talked about in the previous video. So what we have is we have a shape that is a quadrilateral unless we give x a certain value. So going through here, I know that this diagonal and this diagonal is bisected. This whole diagonal is bisected. This diagonal could be bisected if these two measurements are the same. So if these two sides are the same, then I know that this would make it a parallelogram. Well, for it to become the same, I would have to set these two equal to each other. So that means that 2x minus 1 would have to be equal to x plus 5. And now that I have an equation, I can solve using our Algebra 1 techniques. I'm going to subtract x on both sides. So this gives me x minus 1 equals 5. Then I add 1 on both sides, and I get x equals 6. So that value of x would make this quadrilateral a parallelogram. For number 6, it's very similar. We have diagonals that bisect each other. So that means that these two would be equal to one another. So that means I would set them equal to each other and then solve. So I have 3x minus 11 equals x plus 5. Again, I'm minus x on both sides. I always subtract the lower coefficient of the two variables. That way I always end up with a positive result here. If you subtracted 3, then you would end up with a negative result. So if I subtracted 3 from both sides, so that's why I went down that path. Add 11 on both sides, so I get 2x equals 16, divide by 2, and I get x equals 8. That's number 6. Number 7, again, it's another example of one where we have diagonals that bisect each other. So I need to set 8x equal to 3x plus 5. So minus 3x on both sides, and you get 5x equals 5, divide by 5, and you get x equals 1. Now with number 8, we get something a little bit different because now we're seeing angle measurements instead of side lengths. So that means I'm going to be using one of the angle measurements ones. So I'm either using either this one or this one. And because of the way that it's giving it to me, I need to find the value of x. So I'm going to have to use this one here to find the value of x. So essentially, I need these to be supplementary. For those to be supplementary, that means that these two and these two added up together must both be 180 degrees. So if I add 101 plus x, I should come up with 180 degrees. 180. So to find the value, I'm going to subtract 101 of both sides. And I get x equals 79. So that there's my result. For this one here, we need that these two angle measurements here are supplementary. So for 5x and 4x, I need that those are supplementary. So that means I'm going to have to add 5x plus 4x to obtain 180 degrees. So that's 9x equals 180. Divide by 9, and you get x equals 20. And then for number 10, we have this angle measurement here is 5x minus 7. That's x plus 1. As you can imagine, the pattern here, we're kind of adding these up and getting 180 degrees for this part. So I'm going to have to add 5x minus 7 plus x plus 1 and set it equal to 180. Combine like terms, 5x plus x is 6x. Negative 7 plus 1 is negative 6 equals 180. Now I can add 6 on both sides. I get 6x equals 186. Divide by 6, and you get x equals 31. And that's how to find the value of x to make a quadrilateral a parallelogram. Join the next video as we talk about how to then plot points on a graph and then determine if the quadrilateral is a parallelogram. Have a wonderful day.